Hello and welcome to 2.6a Rational Functions and Vertical Asymptotes. In this section we are going to talk about those two things, rational functions and vertical asymptotes. So a rational function is basically a function that has a polynomial on the top divided by a polynomial, because rational means fractional, and so we're talking about something that looks like this. And so then what does this graph look like? Well, it kind of depends on a few things. One, what the top and bottom functions are will give us a rational function, and then we can get a vertical asymptote. How do we find vertical asymptotes? Well, using this rational function notation, a vertical asymptote will be when d of x equals 0. So that's what we're trying to find. And then what is a vertical asymptote? Will be a vertical line that the graph will not cross. What is a horizontal asymptote? A horizontal asymptote is basically end behavior. What is happening as x goes to infinity? So end behavior. And what happens as x goes to infinity or negative infinity? And so what's happening, kind of like when we were talking about, was the graph increasing or decreasing when we were talking about what's going on there. They differ from vertical asymptotes for the fact that a vertical asymptote you cannot cross. A horizontal asymptote you may cross like around 0 or towards the center of our coordinate plane, but as you go out to infinity, the graph will get ever close to a horizontal asymptote and then not cross it. So you can cross a horizontal asymptote, but not a vertical. And how do they affect the domain of the rational function? Well, vertical asymptotes will affect the domain by the fact that that's a place where it doesn't exist. So the domain will be excluded from vertical asymptotes. Horizontal asymptotes has no effect on the domain; it affects the range of the function. So we'll talk more about that in class. So then it says from the definitions, it says a most basic rational function is like 1 over x. So we're going to graph it. We're going to talk about the vertical asymptotes. So to find the vertical asymptote, I'd set the bottom equal to 0. So a vertical asymptote is at x equals 0, which I'll put in this pink dotted line here. There is my vertical asymptote on my graph. The domain of my function, the domain of my function will be everywhere except for where the vertical asymptote is, and that would be at 0 in this case. So wherever the vertical asymptotes are, the domain will be anything but 0. So negative infinity to 0, not including 0, and 0 to positive infinity. The range, well, the range will be, we'll come back to that in just a second. But I believe the range of this will be negative infinity to positive infinity, but we'll talk about it. We'll see what happens when we get the graph. We'll put a question mark by that. And then the limit as x goes to approaches 0 from the negative side. So as we're approaching 0 from the negative side, we could pick some values for x from the negative side. So we're saying if we did something like 1 over negative 1, that would be right here, and so we're at negative 1. If we say if I put x to be negative 2, we'd get negative 1/2, so the graph is going to kind of look like this. If I put in a negative 3, it would be negative 1/3. And so if I put in a half, say x is negative 1/2, that's there would be 1 over negative 1/2, which is the same as negative 2. So you can see as I'm getting closer, the thing's dropping. So the graph will do something like this and fall off and approach the vertical asymptote from that way. What happens from the positive side? Well, if I pick x to be 1, 1 over 1 is 1, so I'd have a spot right there. If I pick x to be 2, x is 2, then it would be 1/2, so at 2 I'm like right here. Let's see, if I pick x to be a positive 1/2, that would be 1 over the positive 1/2, which basically means I'm at 2, and so you can kind of see that my graph is going to approach like this. So this is the graph, a sketched graph of the of 1 over x. And then it says use your calculator a table feature to see what's happening. Well, you'll see I would do this on your own. I'm not going to do this in the video, but you can go ahead and and check out what's happening, and you'll see what's going on here with this. And I would highly recommend that you do that. And then, so here are some examples of graphs that with asymptotes. This one doesn't have a vertical asymptote because if I set the bottom equal to 0, x squared plus 1 would end up being an imaginary number. So there is no vertical asymptote, but it does have a horizontal asymptote at y equals 0. Over here we have a vertical asymptote because if I set the bottom equal to 0, I would get positive 1, and so there it is right there, and then a horizontal asymptote at 0, and we'll talk about how you get horizontal asymptotes in class. And then likewise, here you go, you have a vertical asymptote at -1 when I set it equal to 0, and you get a horizontal asymptote at 2. What I would try if I were you guys is kind of look at these three functions that are given to us and try to figure out how we get the horizontal asymptotes to be what they are. We will talk more about this in the future, but I just try to generalize it. Maybe if you come up with a way to do it, it might be better than me just telling you how to do it. So this concludes our video for section 2.6a. If you have any questions, please feel free to ask them in class.